Hey everyone, I'm Ben, and welcome to my channel where I share things I've learned during my career as a mechanical engineer. In today's video, I'm going to go over modeling gears and knurl patterns in SolidWorks. SolidWorks has some great patterning features that allows for efficient modeling of the knurling and gear teeth. Let's start with the gear. First, I'm going to create a simple cylinder to serve as the base of my gear. I find it easier to start with the cylinder and then cut away the gear teeth rather than trying to extrude it all in one step. This allows me to set the outer diameter of my gear and then work from there. So I'm going to sketch on the front plane and create a circle and add the diameter of 50. Now from both of those, I used mouse gestures to create the circle like that and then the dimension like that. I find my mouse gestures allow me to have a smoother and quicker modeling experience. Then I'm going to extrude from the features menu. From the sketch plane, I'm going to leave it at 10 millimeters for now. This is just an example for modeling. Next, I'll sketch on the front face to create the cutaway for my gear teeth. First thing, I'm going to create a center line from the center out to the edge that is vertical. And then I'm going to create two circles. These are going to be my construction circles, so I'm going to set this one, options for construction, same with this circle, and I'm going to set them as my addendum and dedendum areas. So this circle will be the center of my teeth, and then this will be the bottom of the gear teeth, with this being the outer diameter. Next, I'm going to create a line that is horizontal from this center line and is also coincident on this circle. After that, I'm going to do two 3-point arcs, like so. I'm leaving everything undimensioned for now. These two arcs will create the sides of the gear teeth. Then I'm going to dimension this line to be 1 millimeter long, these two arcs to be tangent, and then the addendum arc is going to have, this one here, it's going to have a radius of 5.5, and this point is going to be 2 millimeters from the center line. Next I'll create this one to be 3 millimeters from the center line. Now I have one side of the tooth. To create the other side, I'm going to use the Sketch Mirror Entities feature. I'm going to select my two arcs in a line. I'm going to mirror about this center line that I created. Last thing I need is this outer edge, so I'm going to use Convert Entities. Then I'm going to trim to closest. So I just have this cutaway feature. So this is about a gear tooth in reverse. And next is one of the cool features SolidWorks has is the circular pattern feature. So I go up to linear sketch pattern, use the drop down area to find circular sketch pattern, select this outer edge as the parameters. We're going to check equal spacing, dimension radius, and for entities to pattern, I'm going to select each of the entities in this sketch. Have equal spacing, and I'm going to set my instances to 20. We can see here it's patterned the sketch around the gear. If I click the green check, we now have a circular pattern. Let's delete some of these extra dimensions so it's not over defined. With this, I can use a extrude cut through all, and here we have the outer edge of our gear. Let's create a quick slot here for a shaft just for fun. I'm going to use a circle of dimension 5, and then I'm going to create a center rectangle 20, 10 by 2. With this, I'm going to use extrude cut again. This time, I'm going to select it through all. Because I have multiple contours, I've used the select contour option to select all the different contours in my sketch. Make the green check mark, and we have a little spot for a shaft and a keyway. And that is the essence of modeling gears in SolidWorks, or at least how I like to do it. Now, all of these dimensions are just arbitrary to demonstrate modeling the gear. If you're actually designing a gear, I recommend using some gear design equations out of a machine design book. Now let's dive into Knurl modeling. Quickly create a new part. Again, sketch on the front plane. We're going to start with a base cylinder again. This time I'll set it to 20. And use the same extrude method to extrude out 20 millimeters from the sketch plane. First, I'll do a straight knurl. And so again, I'll start with sketching on this top face. I'm going to create the center line. I'm going to draw a triangle here. The tip of this triangle is 0.75 millimeters in from the end. Call the full length of the triangle 5. This is 0.5. I'll set this dimension to 45. And because these are already 90 degrees, all I need to do is set them to equal, and that will fully define this sketch. With the extrude cut feature, select through it all, and I'll create this cut down the length of my cylinder. This is the vertical portion of my straight knurl. Next, to create the horizontal section of the straight knurl, I'm first going to create a section plane with the right plane, section view, and then I'm going to sketch on the right plane. The purpose of the section view is to make this sketching a little bit clearer. I'm going to create a center line that is 20 millimeters, the same height of my base. A second center line from the midpoint that is 10 millimeters long. So now this center line will be out to the edge of my cylinder. And I'm going to create the same triangle I did for my vertical portion of this straight knurl cut. Set these equal to each other. Again, same geometry on this triangle. But this time, instead of an extruded cut from the features menu, I'm going to use a revolved cut. For the axis of revolution, I'm going to select this tall center line so that my cut wraps all the way around the part. Leave it at blind and 360 degrees. And then if I leave my section view, we have the two cuts that are going to make up our knurl pattern. So next, I'm going to use the feature patterns to create this. So we'll go from here. Under the linear pattern, I'm going to select a circular pattern. For direction, this top edge, similar to the sketch pattern, equal spacing. I'm going to set this to 24 as it is, and then under features and faces, I'm going to select this cut. As you can see, it's going to pattern this 24 times around. This is just what I thought looked good to create the vertical cuts for our knurl pattern. Next, I want to create more of the horizontal cuts. For that, I'm just going to use a linear pattern. I'm not going to linear pattern that. For direction 1, we'll select this edge here. For direction 2, we'll select this edge, and it's going to point downwards. Now for features and faces, I'm going to select that linear cut. Now I just need to decrease my distance to 2.5, 5 instances, and that should create the cuts I need for my square knurl pattern. Now notice this warning window pops up. To avoid performance impact, use option pattern seed only. I just always select yes for this. And there we have our straight knurl. Next, I want to do a diamond knurl, which is a little bit more complex, but the very same feature structure. So let's do a new part. just quickly make this base cylinder again that we're using. Okay, for the diamond knurl, I'm going to need a swept cut. So first I'm going to need a path for this swept cut, so I need a curve. I'm going to create a helix and spiral curve, select the top face. I'm going to sketch a circle that aligns with this top face, and just to be sure it's fully defined, set that to co-radial. And then when I exit the sketch, the helix and spiral properties window will open up. Now for this, I'm going to define it by height and revolution with a constant pitch. I'm going to set the height to 20, because that's the height of my base part. And I'm going to give 1/3 revolutions, because this looks about right, about the path I want to sweep my knurl cut along. Hit the green check, and there we see our curve. Next, I'm going to create that same triangle we did before, and notice that the endpoint here aligns with the endpoints of my helix and spiral. Again, we're going to create that triangle. With all the same dimensions we used before. And so the feature I'm going to use is the swept cut. And to get to that feature, first I have to exit the sketch, features, swept cut. I'm going to use the sketch profile under profile and path, ensure that our sketch 3, this profile that we just created, is selected as our profile. Then for this selection box, we're going to pick this curve. As you can see from the preview, this is the cut we're making. Hit the green check. And that's the basis of our diamond knurl pattern. So next, I'm going to do another circular pattern. Select this as the direction, equal spacing, and set to 24 because 24 was the last number we used. I'll hit the green check. And so we have these circular pattern of spiral cuts along our part. So to create the diamond, I just now need to mirror this circular pattern over a midplane. So first I'll create reference geometry, plane. If I select the top face and the bottom face, SolidWorks will automatically set this to a midplane between these two faces. Hit OK. And using that plane, I'm going to use the mirror feature. Again, it's using that mirror face plane, plane 1. Features to mirror, I'm going to select the circular pattern from the design window over here. This is a little hard to see from the preview, but we're going to mirror that pattern to create diamond cuts. So with the green check. This takes a little while to load. It's a little bit more complex for SolidWorks to do. But as you can see, we now have diamond knurls on the outside of our cylinder. And that's how you do knurling patterns, both straight and diamond. I like to include these knurling patterns at the end of my feature tree. That allows me to make other design edits without constantly rebuilding that knurl feature, which can take a little bit of time, especially if you make it more complex or smaller diamonds. If you've made it this far, thanks for watching. In this video, I talked about sketch patterns as well as feature patterns to model gears in knurling. We also use the sketch mirror and mirror feature to help pattern our cuts to allow for some efficient modeling. If you made it this far, thanks for watching, and if you want more content on modeling and mechanical engineering, please subscribe. Thanks.